The notion that supplementing with NAD precursors could reverse or slow down aging has gained a great deal of traction, especially among individuals seeking to maintain youth and vitality well into their later years. This has led to the rise of extreme supplement regimens, like that of tech millionaire Brian Johnson, who consumes over 50 pills a day, including NAD precursors, in an attempt to stave off the inevitable decline of aging. The appeal lies in the fact that NAD, nicotinamide adenine dinucleotide, is a molecule essential to numerous cellular functions, particularly in energy production. Levels of NAD in skeletal muscle, for example, drop significantly with age, sometimes as much as 30%. As such, the idea has taken hold that supplementing with NAD or its precursors might help counteract this decline, supporting muscle health and potentially slowing the aging process itself. However, new research from the University of Copenhagen challenges the prevailing belief that the decline in NAD is a primary driver of aging or frailty. In a study published in Cell Metabolism, scientists investigated what happens when NAD levels in skeletal muscle are dramatically reduced. Incredibly, even when skeletal muscle NAD was reduced by as much as 85% in mice, no noticeable acceleration of aging or impairment in metabolism occurred. The results suggest that the conventional wisdom linking NAD depletion to aging may be misguided, and that supplementing with NAD precursors may not offer the benefits many are hoping for. This research is a significant blow to the idea that low NAD levels are a primary culprit behind age-related muscle decline. The study found that despite substantial depletion of NAD in skeletal muscle, the mice showed no significant loss of muscle size, strength, or overall health. Their exercise performance remained on par with that of regular mice, and key biological markers of cellular health, such as gene expression, protein levels, and mitochondrial function, all remained unchanged. Essentially, even with much lower NAD levels, the mice functioned as though their NAD levels had remained unchanged, challenging the assumption that NAD is critical for maintaining healthy muscle function as we age. Furthermore, the study delved deeper into the effects of NAD depletion, observing that while there were some minor changes in how the mice processed energy and a slight increase in energetic stress during exercise, these shifts were not sufficient to cause any long-term damage or deterioration of muscle function. This implies that the role of NAD in aging and muscle health may not be as critical as previously thought, and that there is more to aging than simply a decline in NAD levels. These findings raise serious questions about the validity of current supplements aimed at boosting NAD. For many, the desire to maintain youthful energy and muscle function has led to an industry built around NAD precursors, such as nicotinamide riboside and nicotinamide mononucleotide. Yet, despite the promising claims of these supplements, the new research indicates that NAD depletion might not have the devastating consequences that are often suggested. While NAD may play a role in cellular energy production, the assumption that it is the key to preserving muscle function and staving off aging may not hold water. For those considering NAD supplementation, this new research should serve as a cautionary tale. It highlights that not all popular supplements are backed by solid scientific evidence, and that the complex process of aging cannot be remedied by a simple fix. Despite the hype around NAD and the claims that increasing its levels can reverse aging or improve muscle health, the reality appears more nuanced. The scientific community is still grappling with the true impact of NAD depletion, and whether or not it has the profound effects that many claim remains to be fully understood. Moreover, this study suggests that focusing solely on boosting NAD levels may be a misguided approach to aging and health. If anything, this research underscores the importance of taking a more holistic view of health as we age, considering a broader range of factors that influence aging, such as lifestyle choices, exercise, and diet. In fact, the results point to the possibility that we may be overemphasizing the role of NAD in aging and muscle health, potentially at the expense of more effective interventions. The implications of this study are far-reaching. For one, it casts doubt on the growing industry around NAD precursors and their promise to slow the aging process. While these supplements have become popular, particularly among those seeking to emulate the anti-aging regimens of high-profile figures like Brian Johnson, it's important to recognize that the science does not necessarily support their efficacy. The recent findings challenge the notion that boosting NAD levels should be at the forefront of anti-aging strategies, instead encouraging a more cautious approach to supplementation. In conclusion, this research invites us to reconsider the effectiveness of NAD supplementation and the broader claims surrounding its anti-aging potential. While NAD may play an important role in cellular energy processes, the idea that its decline drives aging or frailty is far from settled. The study shows that, at least in the case of skeletal muscle, low NAD levels do not appear to be as detrimental as once believed. Before diving into expensive supplement routines, it's crucial to remember that the science is still evolving, and what seems like a breakthrough today could be debunked tomorrow. As always, it's important to remain cautious and critical of quick fixes in the world of health supplements.